So now we know the value of K. And the problem statement saying that we should find the fraction of reactant A remaining in the reactor after 1 minute. So now we're still using the same equation that we derived. But this time we know K already. K is equal to 0.035 per second. T is equal to what? 1 minute. But the units of time still different. 1 minute is equal to what second? 60 seconds. This all cancel out. Okay. Now you would get CA over CA0 is equal to exponential of which is equal to 0.123. Now you can say that the fraction of CA over CA0 is equal to 0.123 CA0. That's the answer. The really important thing of this is just that the unit of time and the unit of K, because the K has a new unit of per second, but the time that they ask you is in minutes. You just cannot use minutes because then the unit itself is not cancelled out. You got to change it into the same unit. Okay, so that's why here I didn't put 1. I put 60 because this K has the unit of per second. Now, next example. This one is a bit complicated. Not really complicated, just a little bit. It said that we have a blind tank. Look like this, and in there we have a stirrer. They're saying that we have, let me read it for you. Suppose a blind containing 2 pounds of salt per gallon running into a tank. This is the C, it's a concentration, 2 pounds per gallon. I say C1. And then this is the tank at the beginning, in the beginning. The tank filled with 50 gallons of water and 10 pounds of salt. I mean as PE is equal to 0. And the thing is that we just feed the bright solution with different concentration in here. With the concentration of 2 pounds per gallon and rate is equal to 5 gallons per minute. The mixture kept uniform by stirring. So inside there we have stirrer to make the mixture is uniform. And the mixture is flowing out from the tank with the rate of 3 gallons per minute. And the volume of the tank is 100 gallons. They're asking us to find the mass of salt in the unit of pound in the tank at any time. It means they want to know the function of the mass of the salt as a function of time. And find the maximum mass of salt when the tank is full. So it is possible that somehow the tank will be full because the flow rate that it put in there is faster than the flow that we're taking it out. But we got to set the equation in this case. In chemical engineering, we do mass balance. Mass balance defined as the rate that the mass transfer into the tank minus the rate that the mass moving out of the tank, plus or minus if they have some generation from the reaction or disappear. But in this case, we don't have any reaction occur because it's just like concentration, but there's different concentration and then you just mix them together. So at the output, you would get different concentrations. Just that, but no reactions occurred. Okay? Equal to the rate of accumulation. So when we are talking about mass balance, the unit that we should get from the mass balance is the mass per time. So we've got to take a look at what is the line in and what is the line out. In this case, we have only one line in, which is C1 or F1. But how can we get the unit of it as the mass per time? You got to use C1 and F1 times to each other. So in is C1 times F1 minus out is F2 times C, because you don't know what is this C. C is whatever you got to find, and this C is a function of T. Why is a function of T? Because here you put it the concentration 2 pounds per gallon, but inside here you have salt. When it's mixed together, the concentration inside the tank change. It can't be 2 pounds per gallon. It should be greater. Now, if you take a look at the unit of it, C1 is pound per gallon. F1 is gallon per minute. Now you get the unit of mass balance, which is pound per minute. Okay. For the accumulation, you got dCT by dt. Sorry, dm, not ct. M is mass. Mt is a mass of salt. I can't use ct because C has the unit of pound per gallon. Because I want to make the unit here the same as whatever on the left side. And then since we have CT, but this one is MT, I am going to convert MT. Shall we convert? They're asking for mass. We are going to convert this CT to be MT. You know that C equal to M over V, right? C is equal to M over V. Now our V is equal to what? So if this is CT, M is changing by time, but our V is also changing, but V is the volume of the liquid inside the tank. So our V is just equal to, at the beginning, you have V0, right? At the beginning, we have water inside the tank, 50 gallons. So this V is equal to 50, plus what? Plus whatever you just set in there by time. which is which is which is 5 minus 3, right? Right? Because you fed in there 5 gallons per minute and you take it out 3 gallons per minute. So whatever difference is 2 gallons per minute. So the volume of the liquid in the tank just kept increasing as a function of time by this equation. Or you can say 50 plus 2t. Our V is equal to 50 plus 2t. Now, from here, we can say that then our CT here, CT which is equal to MT over V is equal to MT over 50 plus 2T. Now we put, this is equation 1, this is equation 2, this is equation 3. We put equation 3 into 1, this C. We would get dmt by dt equal to, you know C1, right? We know C1, right? C1 is equal to 2 pounds per gallon, and F1 is equal to 5 gallons per minute. F2 is equal to 3 gallons per minute, and CT is equal to MT divided by 50 plus 2T. Now we get 10 minus 3MT 50 plus 2T. If we know, if we solve for M as a function of T, then we will know M is just amount of salt which is inside the tank, right? So we know what would be the mass of salt inside the tank with time, if we can solve for the answer of this differential equation. Right? It is a what? This type of equation, what is it? Linear equation. Oh, two, not 20. It's a linear equation, right? Which has Px is equal to 3, Pt is equal to 3 over 50 plus 2t. And Qt is equal to 10. Then we can find what? The integrating factor, which is equal to exponential of the integral 3 over 50 plus 2t dt. We do integral of this one, what we get? E to the power of, no, E exponential of 3 over 2 ln 50 plus 2t. which is equal to 50 plus 2t to the power of 3 over 2. Now we can find m. M is equal to 1 over integrating factor times integrating factor qt dt plus c, which is equal to 1 over 50 plus 2t to the power of 3 over 2 integral 50 plus 2t to the power of 3 over 2, and qt is equal to 10 times 10 dt plus c. To do integral of this term, you got to make dt become the 50 plus 2t. That means you got to divide it by 2. You got 10 divided by 2. And then you can do integral of this term, which is equal to 50 plus 2t plus 1. 5 over 2 divided by 5 over 2. 2, 2, 2. That is our empty. That is the mass of salt which is inside the tank as a function of time. But now we got to find C. We know that in the beginning at t is equal to 0, m is equal to 10 pounds. Okay. We just plug our initial boundary condition in there to find C. I just make the power of 50 into the power of 3 over 2. This one 5 over 2. I want to make it to be 3 over 2, so I can take 50 out. So 50 times 2 equal to 100. Now both of them has the same number. Then you can do subtraction. So you would get minus 90. That is the value of C. Then we just plug the C into our equation. Then we will get a relationship between M, which is the mass of the salt in the tank, as a function of T, which is the time. That's it. And then the problem statement itself asking more. It is asking that find the maximum mass of salt when the tank is full. We got to know that what time that the tank is full. So if we know time, then we would know the mass of salt inside the tank. From our equation 2, we know that V is equal to 50 plus 2T. We know that the full capacity of this tank is 100 gallons. Right? We just put 100 there. And then we can find T. T is equal to 25 minutes. So that means when it's run for 25 minutes, the tank is full. So if you want to know like the mass of the salt in the tank at this time, we just plus the T is equal to 25 in there. You would get the mass. That would be the maximum mass when the mass of the salt when the tank is full. Okay, so we just, let me put this equation into the number 4. Then it said that put T equal to 25 minutes into 4. We would get MT, it's about 168 pounds. That is the maximum mass of salt when the tank is full.